So let's go ahead and give this example and try some of these integrals out. So what do? We integrate just like we would if it was an indefinite integral. So x squared minus 3, we're going to separate it. What's the integral of x squared? That would be x cubed over 3 minus what's the integral of a constant? Well, it's that constant times x. And then again, it would be plus c. But here we don't need the plus c. And I'll motivate that in just a second. But we have to evaluate this from the numbers 1 to 2. You do need to write that vertical bar with the 1 and 2 that says I haven't evaluated them yet. All I've done is integrated them at this point. So what do? I always want to plug in the upper limit first. So that would be plugging in the number 2 first, right? So I'd plug in the number 2 into the function first. And then I'd subtract from that and I'd plug in the lower limit second. So the exact same function, x cubed over 3 minus 3 times that x value, and now I'm going to plug in that lowercase number, okay? So this is what the actual math looks like. What you could have done, you could have just done, like I'm just going to use my table feature because I'm plugging in a number into the same function. So I'm going to plug it into x cubed over 3 minus 3x. I'm going to plug in the upper limit first, and then I'm going to plug in the lower limit. And so rather than writing it out, what I'm going to do is just use that table feature in my calculator. So I'm hitting table, I'm clearing everything out. I'm putting in x cubed over 3, and then I'm doing minus 3x. And I hit enter. Start doesn't matter, step doesn't matter, ask x needs to be selected. I'm going to hit the number 2. When I hit the number 2, I get negative 10/3. And when I hit the number 1, I get negative 8/3. So what would I have here? I'd have the upper limit, which was negative 10/3, minus the lower limit, which was negative 8/3. Okay. And so if I quit out of this and I go negative 10/3 minus a negative, make sure you do another negative there, 8/3, I'm getting a total of negative 2/3. Again, the answer here is negative, which means technically this isn't area, but we could see this as the region beneath the curves, it being below the axis, right? Okay. So the answer I'm getting here is negative 2/3. So let's look at the next problem here. It says the integral from 1 to 4 of 3 times the square root of x dx. So again, the way that I want to look at this is I want to think about this as 3 as x to the half, right, dx, okay? So what you can do here is pull out that constant, so this would be 3 times the integral from 1 to 4 of x to the 1/2 dx. So when I do that, I keep the 3 out in front. And now I need to integrate x to the 1/2. Well, that means I need to add 1 to the power. Remember, with integration, we add. So 1/2 plus 1 would be 3/2. So it would be x to the 3/2. And then I'd be dividing it by the same number. So I'd be dividing it by 3/2. But hopefully now, with all the practice you got from the previous sections, you're used to saying this is the same thing as multiplying it times 2/3. So x to the 3/2 over 3/2 is the same thing as 2/3 x to the 3/2. And then this we still need to evaluate from 1 to 4. Again, we don't need the plus c. The reason that we don't need the plus c, by the way, I didn't motivate and I said that I would. Think about it right here in this previous step. If we wrote plus c right here, and I plugged in the number 2, I would have had a plus c here and a plus c here, and when you subtract them, the c's would simplify, or cancel, I should say. So the c's cancel each other out, so it's totally arbitrary. You don't need to add the plus c's with definite integration. So that's why I didn't add the plus c here, okay? I'm going to go ahead and simplify this a little bit. The 3's do simplify, so this is the same thing as 2x to the 3/2, and this is evaluated from 1 to 4. So what do I have to do that? The fundamental theorem of calculus says, let's plug in the upper limit minus the lower limit. So it's going to be 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. Again, you always do the upper limit first, and you do the lower limit second. Plug it into the function. Okay, so 4 to the 3/2 times 2 minus 1 to the 3/2 times 2. Go ahead and put that into your calculator, see what you get. I'm getting a total of 14. So the answer on that problem would be 14. And this was -2/3. Okay. Let's move on. Let's see if we can now do some trig functions. Again, this would have been extremely difficult if we tried doing the limit definition. Well, now we don't need to do the limit definition of this one. We can just use the fundamental theorem of calculus. The fundamental theorem of calculus says to evaluate the definite integral, act like it's an indefinite integral. So what is the integral of secant squared? In other words, what do I take the derivative of to get secant squared? Well, the answer is tangent of x. The derivative of tangent of x is secant squared of x, right? But here I need to evaluate it from 0 to pi over 4. So how do I do that? I plug in the upper limit first, so this would be tangent of pi over 4, minus the lower limit, so this would be tangent of 0. So when I plug that in, tangent of pi over 4, that would be root 2 over 2 over root 2 over 2, so that's a 1. And tangent of 0, sine over cosine, that would be a 0, so that would give me a value of 1. Again, you could have just straight up put that into your calculator. I was just trying to do some of it in my head. So the answer there would have been a 1. Okay. Let's make it a little bit more difficult now. What if we wanted to evaluate the integral of an absolute value function? So you need to remember what an absolute value function is. So we need to break this up where the inside is equal to 0. So let's look at where 2x minus 1 is equal to 0. So that'd be 2x equals 1, so that would give me x equals 1/2. So this thing breaks up at 1/2. So what we're looking at, if we're trying to look at the picture of this thing, we have something that looks like this right here. Something that's going to look like that right there, where this breaks up at 1/2. So we have one function to the right of it, and that's when the inside is the same. That's when the values are positive. So this is y equals 2x minus 1, right? And the other curve for the other side of it is the exact opposite of it. So what's this curve right here? This is y equals, well, it'd be the opposite of 2x minus 1. So I'm going to go ahead and distribute that negative real quick. That'd be -2x plus 1. So it looks like we're going to do two separate integrals here. We're going to do a blue area and we're going to do a green area, okay? And this has to go from 0 to 2, so it looks like to me we need the integral from 0 to 1/2 of that function, which was -2x plus 1 with respect to x, plus we need to do the green area, which would be the integral from 1/2 to 2 of that function, which was y equals 2x minus 1 with respect to x. So here we have to integrate both of these as separate functions. Let's go ahead and do so now. So what's the integral of -2x? Well, that would be -2x squared over 2, plus the integral of 1 is just x. And again, this would be evaluated from 0 to 1/2, plus, now let's integrate 2x. That would be 2, and then it would be x squared over 2. Minus the integral of 1 would be minus x, and this is evaluated from 1/2 to 2. So there's actually a lot of numbers that we need to plug in here. First thing I'm going to do is I'm going to simplify what I can, so the 2's are going to simplify. And so when I do this, I have to plug in the top number first and then the bottom number second. So rather than writing all this out, because this will be a lot to write out, I'm just going to go ahead and show you. I'm going to use the table on this. I'm plugging it into -x squared plus x. I need to plug in a 1/2, and then I need to plug in a 0. And then plus, and I need to subtract those two, right? And then I'm going to plug in x into x squared minus x, and I need to plug in a 2, and I need to plug in a 1/2. So right now what I'm going to do is use the table feature to get those function values real quick, and then I could subtract them and find out which each one of those integrals are. So the first thing I'm doing is it's my table, clearing it out. I'm putting in -x squared plus x. and then I hit enter. I make sure I have ask x. I type in 1/2, which would be 0.5, and I'm getting 0.25 when I plug that in. I plug in 0, hit enter, and I get a number of 0. So this first integral would be equal to the upper value, which would be 0.25, minus the lower value, which would be 0. Okay? I'm going to go back to my table. I'm going to type in x squared minus x. Hit enter. I'm going to plug in the number 2. Or sorry, I'm going to plug in the number 2, enter, and I got a 2. And then I'm going to plug in 0.5 or 1/2, and I get negative 0.25. So what do I do when I get that integral? I do the upper value, which was a 2, minus the lower value, which would be plus a 0.25, because when you subtract a negative, that becomes a positive. So what do I end up with? Quitting this out, I end up with 0.25 minus 0, which would be 0.25 plus 2 plus 0.25. I'm getting a total of 2.5. So again, if I wrote this out the proper way of doing it, I just said, look, I'm using the table feature to get these values. Technically what I did was I plugged 1/2 in here, and then I plugged in 0 here, and I subtract them. I plugged in 2 here, and I plugged in 1/2 here, and then I subtracted them, okay? And then what I did was I added those two different integrals together. So my work looks a little bit off of what it should because I use the table feature on my calculator, but what I've noticed is if you use the table feature on your calculator, you tend to have far fewer mistakes. And that's our final answer, 2.5. So not 100% guaranteed, but a high probability that you could have one of these absolute value functions that you're integrating on your test. And when you have this on the test, again, what you do is you set the inside equal to 0. That gives you the point that you need to break it up at, right? So that gave us the 1/2. Anywhere to the, in this case, to the right of it was positive. So the inside, the function value is the same as the inside. Anywhere to the left of it was negative values if we plugged it in. So the function would be the exact opposite of whatever's on the inside of the absolute values. So just put a negative in parentheses and then distribute it. You have two separate integrals you set up, you add them together, you get the answer. I hope that makes sense.